Thanks for inviting me back. I'm going to talk a bit about another potential solution, the no-go area service that will hopefully reduce the workload on the mariner and potentially reduce the risk of human error and accidents. It's a service that will provide detailed information on what is below the surface. We heard a lot about the windmills, the offshore structures that will be in the North Sea in the future. What is also interesting is the dangers below the sea level and what is not visible from the mariners when he's looking out the window. This picture shows an area with some different depth curves. It may be difficult for the mariner to see where he can navigate and where not. Here we have a no-go area for 4 meters with a bright red color, so it's obvious where we can go and with a depth or with a draft of 4 meters. What we want to do is to make the service that is specific for the vessel. Instead of the depth curves in the chart, which is at 2, 4, 6, 10, and then 20 meters, a vessel with a draft of 12 meters. It's difficult for the vessel to see where it can go. It can definitely not go down to the 10 meters, but should he stay outside the 20 meter curve, and so on. If I just click on here, then you can see how the area expands, and the navigable area is reduced with the other curve. Just to explain in short the technical side of it, we have on the left side is the wanted underkill clearance from the vessel. That's all related to the vessel. That's the draft, that's the squat, the heave, and other data. That data combined with detailed bathymetry, the tidal level, and weather information will give these no-go areas. How we're building the service for the prototype is that we have the vessel ask shore for the no-go area, so all data will be available ashore. So the detailed bathymetry, the tidal level, and the weather information is in a database ashore. The vessel will then send its wanted underkill clearance at a certain time, and the no-go area is then returned and presented on the chart like this. Detailed personal no-go areas for the vessel. Just to show, there's also the time issue. As the tidal level changes, the navigable area changes as well. And if we have this vessel going along, we have the 10 meter depth curve. This vessel has a wanted underkill clearance of 12 meters. And we can see as we put on the no-go area, the area is reduced. And then as the tidal level changes, as the vessel goes along, you can see that at some point the no-go area will be on the planned route. That may not be a problem if the vessel has passed or is not yet there. So if we then put in this box, it's called we call it the safe haven. So it's a timing tool. So as in the no-go area, if the vessel is inside that box, it's safe tide-wise, and you can see as we go along that there's enough water on the planned route here that the vessel will always be in the blue and safe area. We also discussed the horizontal safety distance. This is an island that a lot of you will know by now. It's in the Mediterranean, where one side of the island is very steep, and the other side is more, there's some shallow water. The safety contour is 10 meters, but on the western side of the island there's maybe only 30 meters to actual hitting dry rock. So by introducing a safety distance as well, a horizontal safety distance, like this for example, the vessel will both have the vertical safety distance and the horizontal safety distance. It could be 50 meters. We're planning to do live testing of this service, and we have a really good cooperation with the Humber port authorities. Here we have one example. Why Humber is really interesting is that they have some changing depth due to sand that's moving around. They do surveys once a week. They have a survey vessel surveying the area once a week. They also have the tide variation in that area is very big, so it's 4 or 5 meters. So it's changing a lot, and it's changing the vessel's possibilities a lot with the changing tide level. This example is normally they will go via the red route, where there's plenty of water. Due to traffic limitations, it's sometimes better for the vessels to follow the green route. The green route is only open 2 hours, 4 hours a day with the tide. But when introducing the no-go area service in this area, it will be obvious when the green channel is open to navigation and when it is closed. Also in the approach, there's 3 main approaches to Humber port, and normally they will use the red route, the center route, but in really bad weather, the southern route is preferred. In the southern route, there are draft limitations to most of the vessels going in there, but at high tide, this channel is open, and they can then use it, and it can be visualized on their screen with the no-go area service. So we're going to do live testing of that service in the area together with Humber Port and the P&O ferries that is calling in Humber Port. Hopefully this fall, September, October. Next year we will have the last ACCSEAS conference, and hopefully we will be able to demonstrate and give you some feedback and conclusions on those tests. So that's it for now. Again, the picture of the future, and yeah.
Thank you very much indeed, Mads. Any quick questions for Mads on that idea?
Good morning. Thank you very much. And my point really is an observation on this and several of the other presentations we've had, in that this presentation and others indicate a proposal to manipulate hydrographic data to come up with some scheme, some plan. It's worth noting that last year at IHO, Robert Ward stood up and made a very strong statement that the state of hydrography of many existing charts is unreliable, and I'm paraphrasing, but I think he said unsafe. It is interesting that administrations represented in this room are happy to put money into schemes that are based on what might be unsafe foundations, rather than meet their IMO SOLAS obligations to carry out those chart surveys. Thank you.
Question, Mads, do you want to have a go at it?
I'm taking. I heard that presentation as well, I believe. This is we're trying to take existing data and manipulate or make a product that may be better for the mariner. I remember when I was saying, calling Immingham, the workload on the mariner to calculate tidal windows and so on. So this is a service that hopefully can help that workload. Also cracking numbers, finding out if it's UTC or if it's CET or daylight saving time. There's a lot of possibilities of mistakes in that work. And this is a service that may help the mariner, and I think it's valid to at least try it again.
a very effective and clear presentation. One question. How do you make this visible in the electronic charts? Because you have to put in also the times. If you have on the tidal levels, you have to put the time in as well. Isn't it very complicated to put this in the electronic chart, and how do you intend to do it?
How it works now in the prototype of that we are is that we all the calculations are done ashore. All the heavy data is ashore, and it's a lot of data for this detailed bathymetry. When the request is returned from shore, it will then display these polygons, the red areas. This is for a specific time. What we would like to do is to introduce this or implement this safe haven functionality or time slider, so to say. So you have the connection between planned route and the tidal levels. So that is the intention in due time. Yes, the tidal level changes. Yeah, correct. But here we have the time in the left side of this. At 1806, the water level and the planned position is like this, and then 1818, 1830, 1842, 1855, and so on. So there's a link between the position and the tidal level and time.
So this is the beauty of the difference between a raster chart and an ENC database. The fact you can have all this data in there. I'm going to let these questions run a bit because I've of course got a view on the hydrographic point. When I'll come back to you in a second for the professional answer. I was going to take 2 more questions. Sorry.
Yes, thank you. Thomas Kay from the French Geographic Office. Do you think that in order to display this information on the ENC, maybe it will be very interesting to connect with the DIPWIG group, working group of IHO, to be sure that the display of your information in the areas won't hide something on the ENC that could be very important for the safety of navigation of the boat.
Yeah.
So maybe there is a link to do with the DIPWIG working with the IHO.
Yeah, definitely.
Thank you. Tim.
Nice, thank you very much. As a ship operator, I'm sort of quite interested in the regulatory aspects of this. Following on perhaps from John's point about the source data, in your example of the Humber, you illustrated that there was quite a narrow window, and therefore that implied routing information being given to a master, possibly directly to the master or possibly via a pilot. Using your example, that window was very limited and therefore would have what one might consider to be quite a tight safety margin associated therewith. How do you think that would play out in reality of directing potentially or advising or mandating that a ship does or doesn't follow the kind of advice that comes from that, particularly following on from what John said, that where's the source data coming from and where the master's ultimate responsibility lies?
Very good question. And we're doing a technical test at the moment, and hopefully the test will also give us some indication of what is to be done on the regulatory side of it. So we haven't thought a lot about the regulations at this moment. What they do in the Humber, the VTS at Humber, they are advising vessels on which route to take at the moment, and this is just a tool to visualize for the vessels that it's actually possible to go there. Right now they just get the advice from the VTS, and also it's also very important that this service is not taking ENC data or depth data from 18 something. It's taking depth data from yesterday or from 2 months ago. So it's the position wise and the detailed bathymetry here is from a modern origin and not from a manual echo sounding with a rope and a piece of metal in the end. So that's very important to understand.
I'm going to come on that. I'm going to come on that too. Just worried about time. Thomas, and then everyone, then after the session. I'll come back to Kim.
I think manipulating is such a hard word. I think that what we talked about yesterday was that e-navigation is about delivering the right information at the right time in the right context. And I think this is an example of where we are trying to deliver not only the right information, but actually customized information, which is particularly relevant to the specific user, more than generic information. It's just about making the right information available in the most usable way for the user. At least that's the intention. But now we'll see how the tests play out. Maybe there are pitfalls we haven't foreseen, and hopefully the tests will uncover that. Thank you.
I'm just going to let Edward give the professional UK show perspective.
Thank you. I'd just like to thank John for raising the issue of the poor quality of hydrographic data around the world. But I think, although I can't speak for every hydrographic office, I suspect most hydrographic offices are well aware of that.
And the benefit of this sort of work is that it justifies the need for more surveys. I come back to the point I made yesterday. There's got to be some economic benefit here. Surveys cost money. Someone has to pay for that, whether it's government, whether it's ports. Whoever has to pay for the surveys needs to get justify the cost of that survey. And it's not actually just the cost, it's also the capacity. The present capacity for doing hydrographic surveys around the world is limited, it always will be limited. If this sort of work can justify having more survey ships out there, paying for the surveys such that the economic benefit can be, it will justify the economic benefit, then that's where the surveys will come from. They're not going to just come because someone thinks it's a good idea. And we would love to have more surveys and love to include more detailed hydrographic information on our charts and our future information that we'll provide.
It won't surprise you that I do have an opinion on this. I'm very grateful for those comments from you, Edward. The harsh reality of life, ladies and gents, is that people are out there navigating on these charts anyway. And I could take you to some parts of the Philippines where you'll find huge vessels navigating on the most appalling scale charts using data which goes back to the early 1900s. There's also the frustration of the hydrographer and the surveyor, and although I'm not a hydrographer, I was one, where you go out and you gather the data, maybe in a remote part of the world. I personally surveyed King Harkin Bay in South Georgia to death, and that data is still sitting on a shelf in the hydrographic office, and the reason for that is, as Edward just pointed out, there's not a commercial imperative to put that data out in public. In the case of the Humber, they resurvey the Humber, that particular shadow patch, I think it's every 2 weeks. So the data that's going into that model described by Mads is the most current data. And I completely endorse Edward's point that if we want to do these sorts of sophisticated e-navigation systems, we're going to need modern surveys. Now, you're not going to suddenly get countries rushing out there and buying a whole load of multi-beam fitted survey ships. That ain't going to happen. So we've got to use other ways of doing it. We've got to go down the crowdsourcing route, and everybody goes, gasp, shock, horror. But we've got to go down the crowdsourcing route. The GPS and the echo sound of fits of yachts today is way beyond the capability of survey ships 30 years ago. That is good data that if we could only categorize it properly, we could use in these sorts of data sets. And just remember, if you're a mariner, a number is a damn sight better than no number. So I think this has been a very, very useful debate, and I think the point about the bathymetry and the quality of the bathymetry that lies behind it is absolutely key, and it'll be something that comes out of the ACCSEAS project.